Delta EMD is one of only 5 leading global producers of premium quality electrolytic manganese dioxide, commonly known as EMD, that is used primarily for the manufacture of alkaline batteries worldwide. Delta EMD also produces greenfill, a product derived from solid waste streams that finds application in capped road filling.
Delta EMD was established in 1982 to meet the increasing global demands for high-quality electrolytic manganese dioxide. Our success is attributed to our commitment to customer service and our technical collaboration with the global battery producers. The Delta EMD facility has an innovative modular plant design that renders the operation with an extremely flexible facility that is capable of efficiently directing output capacity to align with the EMD market demands. It is our philosophy to meet the customer performance and quality requirements by developing and safely manufacturing world-class products in a socially acceptable and environmentally responsible manner.
Delta EMD's operation includes a calcining plant located near Black Rock in the Northern Cape, which reduces manganese ore sourced from various major manganese ore mines in the Kalahari Basin, and an EMD manufacturing plant located in Nelspruit in Mpumalanga. The Nelspruit facility is ISO 9001 and OSHAS 18001 accredited, and the company was voted finalist in the category of Best Quality Exporter at the South African Quality Awards event. The Black Rock calcining facility was designed and built by Delta EMD engineers and commissioned in 2003 to satisfy an ever-increasing demand for high-quality reduced ore. Manganese ore collected from the mine in tipper trucks is discharged into an underground bunker system. The material is weighed and conveyed by overland conveyors to the crushing and drying plant. The ore is screened and larger pieces are passed twice through a gyrosphere crusher and crushed to a sizing of less than 2 mm. The ore is then conveyed to a rotary gas-fired dryer for drying. After drying, the ore is transferred to storage tanks, and upon discharge from these tanks, a percentage of charcoal is added. The calciner is fed with this mixture of raw ore and charcoal, the latter acting as a source of carbon for the reduction reaction. The calciner reduces the manganese ore to produce manganese oxide. This reaction proceeds when external electrical heat of approximately 1 megawatt combined with another megawatt of internal heat generated by a liquid petroleum gas burner is applied to a 25-meter-long rotary kiln. After calcining, the material is cooled and transferred to the milling section. The manganese oxide is milled and classified to a minimum specification of at least 90%, passing 75 micron, and then stored in 5 storage bins, from which it is loaded and transported to Nelspruit either by road or rail. At this point, reduced ore quality is verified via a rigorous quality assurance protocol. The Nelspruit EMD manufacturing plant, which was originally built as a 5,000 ton per annum greenfield facility, has been upgraded and expanded several times to become one of the most modern EMD facilities in the world. It currently has a production capacity of 30,000 ton per annum, with potential for further expansion. Reduced ore received from Black Rock is stored in 3 by 1,000 ton storage bins, equipped to handle pneumatic discharge of material from bulk transport tankers. At the chemical plant, the reduced ore is fed into the first leach stage. This is a continuous stirred cylindrical reactor with an agitator inserted. The ore is mixed in a pre-wetter with electrolyte returning from the electrodeposition process before entering the leach reactor. As a result, manganese sulfate-rich brine is produced. The next stage of the chemical process is the goethite stage, where the main aim is to precipitate out the iron from the manganese sulfate solution, together with other heavy metal impurities present in the ore. Here the pH is measured and controlled at the outlet launder to the next process stage. Calibration and cleaning of pH probes are extremely important in ensuring the purity of the solution. The slurry from the goethite precipitation stage, containing approximately 40% solids, overflows into a third tank from where it is fed into a thickener. This unit separates solids from liquids through gravity. A flocculant is added to enhance particle agglomeration and increases the settling rate. The solid particles settle down and the slurry is released into a sump and pumped to a holding tank before being further filtered at the belt filter section. From the thickener, the semi-clarified solution overflows to the Funda filter feed tank. This liquid, a much cleaner solution with low values of solid loading and impurities, is kept at 80 degrees Celsius by introduction of live steam. The solution is then pumped into the Funda filters for further filtration. The Funda filters are essentially pressure filters where any remaining solid particles are trapped and an ultra-pure manganese sulfate solution flows into the cell house feeder tank, which is regulated at 85 degrees Celsius. The iron level in this solution is measured and confirmed to meet required standards before it is pumped into the electrolysis plant via the header tanks. The header tanks provide fluid head pressure and direct the solution flow to the distribution manifold, from where it flows to individual cells in the cell house. The electrode deposition process in the cell house utilizes DC current to oxidize manganese ions in the solution and coat manganese dioxide onto the surface of the titanium anodes. A compound is added onto the electrolyte surface to suppress the evolution of acid mist. Manganese sulfate concentration is a crucial quality determinator, and special emphasis is placed on the flow control into each individual cell through the use of flow measuring devices. Applied current density impacts on the surface area of the EMD and is manipulated according to customer requirements, whilst plating temperature is regulated close to the boiling point of the electrolyte. Anodes are removed after 3 weeks of electrode deposition and are then dipped into hot water wash baths to effectively remove residual contaminants measured by the QC laboratory. The anodes are weighed and the EMD is removed from the electrodes using a pneumatic hammer. The harvested chips are then ready for post-processing and are transported to the crushers via conveyor belts. Large EMD chips are passed through a crusher system to improve wash efficiency in the washing stage. The two-stage crushing sequence reduces the EMD chip size to between 8 and 13 mm diameter. The chips are now ready for the washing stage. Electrode deposition of manganese dioxide takes place in a sulfuric acid environment, resulting in EMD product with a low surface pH. The washing stage removes residual acid and restores the pH of the EMD chip to meet customer pH specification. Washing takes place in a series of wash tanks and is accomplished via a 5-step batch sequence. 3 water washes remove excess sulfuric acid from the porous EMD surface. A single neutralization step using caustic soda follows, and the sequence concludes with a final rinse with fresh water. Drained water is stored and reused in the first leach stage. The pH-corrected EMD chip is now ready for milling. The final stage of size reduction is performed by a powder mill, equipped with a table feeder and an air-swept rotary classification system. Heated air is circulated through the mill to dry the product to customer specification. The classifier speed is used to manipulate the particle size distribution of the final product. From here, a pneumatic transfer system transports EMD powder into a blending bin, where the material is blended by continuous rotation. blended material is screened through a 700 micron mesh just prior to final packing and sampling.
Our product is packed into different bag sizes according to customer specification and then transferred to the finished goods warehouse after the lab has quality approved the material. In the finished goods warehouse, staff select bags according to customer orders. Containers are packed for rail and export from Maputo, or trucks are loaded for export from Durban. From there, logistics service providers will ensure that the material is safely delivered to customers all over the world.
Two major product ranges are manufactured, namely high-grade EMD, finding application in alkaline and lithium primary chemistries, and low-grade EMD, which is consumed in cylindrical and flat zinc carbon cells. To satisfy the vastly differentiated requirements of the high-grade market segment, Delta EMD offers a variety of EMD products covering a range of potential applications such as flashlights, toys, digital media, and even pacemakers. Strategic leadership, resource focus, and innovative investment have culminated in the development of Delta EMD's latest flagship product, Delta Silver, for specific application in the global premium AA and AAA market sectors. Excellent discharge performance, extended battery shelf life, and ease of processing are three decisive attributes associated with this premium performance product.
Delta is committed to continual improvement of its safety, health, and environmental performance. This is in order to minimize the risk of injury, occupational illness, and environmental damage. Provision of a safe, clean and healthy workplace for all employees, visitors and contractors is of prime importance to Delta. At Delta, we believe that no work is so important that it should place anyone at risk of injury or illness. Programs such as induction, risk assessments, safe work procedures and training are in place to ensure that we live up to this belief.
Delta EMD adopts best practice standards to meet its commitments to comply with local environmental regulations and strives towards zero waste generation, with programs in place aimed at achieving this goal. As such, the slurry from the thickener underflow is not handled as waste, but rather further filtered at the belt filter section. The entrained manganese sulfate solution is washed and vacuum filtered to recover as much of the soluble manganese as possible, thus improving the overall plant efficiency. As a result, a solid residue is produced, which is repulped and then transported to the inerting plant for further processing. At the inerting plant, the residue is treated with unslaked lime in a mechanical mixer to produce a dry, granular product called green fill. Green fill is a non-hazardous product that is approved for utilization in the construction of tarred roads. It has excellent strength qualities and is perfect for utilization as base and sub-base layers of tarred roads. Since 2007, several gravel roads have been upgraded to tarred roads with green fill, with excellent market acceptance. It is expected that demand for green fill will soon exceed supply as market development for this product continues. Delta EMD is committed to maintaining and improving our position as a raw material supplier of choice to the world's portable energy storage industry. The proximity of the plant to one of the world's largest known deposits of high-grade manganese ore will continue to provide a significant cost and efficiency advantage. Delta EMD's technical services are constantly identifying and analyzing opportunities for strategic technical innovation to maintain and grow the company's competitive advantage by reducing operational costs and introducing new products aligned with the ever-increasing performance demands of the portable energy storage industry.
New product development concentrates on the research and development of EMD derivatives for application in primary lithium and rechargeable lithium-ion battery industries, the latter being considered the future chemistry of choice for electric vehicle batteries.
Constantly explored as well are alternative manganese-based chemicals with potential application beyond the primary and secondary battery markets. Delta EMD is continuously improving its advanced chemical engineering process to manufacture battery materials that shapes the current and future portable energy storage industry and its changing demands. This is achieved through an embedded culture of participation and collaboration with its key global business partners. The Delta EMD team embraces a value system of striving for excellence in safety, health, environment, product stewardship and customer value add. Delta EMD is an innovative and market-driven organization with accountable and performance-driven individuals with the highest level of integrity that is certain to sustain and grow value into the 21st century.